Hi everyone, it's Coach Fred here, and today I'm going to be talking about this really cool thing that relates to the quadratic formula. So I just kind of want to talk to you about the quadratic formula. So we've been investigating and discussing it in class. I showed you where it came from by completing the square, we derived the formula. And this quadratic formula helps us solve a quadratic equation. Solve a quadratic. It's a way to solve a quadratic. It will always work. And it helps us find the roots or the zeros. And the x-intercepts, we call those, if it has one. Okay? All right. But the quantity under the square root you investigated today on Desmos is called the discriminant. Long, funny word. I use D for short. The D, the discriminant. Okay, so b squared minus 4ac is the discriminant. The square root is not part of the discriminant. And so today you investigated what happens based on the value of the discriminant. So let's just look at a quadratic and their x-intercepts. A quadratic can have three different scenarios that can happen with a quadratic and its x-intercepts. We can have a quadratic that does not cross the x-axis, so it has no x-intercepts. We can have a quadratic that has one x-intercept where the vertex actually just touches the x-axis. And then we can have a quadratic that passes through and crosses the x-axis twice. That's the most it can cross the x-axis. Okay, so today you worked on what relationship you think the discriminant has with these graphs. I want you to think about it a second. We've already talked about it a little bit, so go ahead and write down what you think. And then I'm going to recap. Okay, so the three possible outcomes are we can have a situation where the discriminant value equals 0. So when the discriminant is equal to 0, let's think about that for a second. Negative b plus or minus the square root of b squared minus 4ac all over 2a. If the discriminant was 0, that means I'd have plus or minus 0. So the plus or minus wouldn't really matter. So what I'd actually be left with would be x equals negative b over 2a. So I'd only have one x. So when the discriminant is equal to 0, it has one real solution, which means one x-intercept. And we're going to be talking about what that means because that equation then, that original equation, was a perfect square trinomial. FYI, okay? All right, then we could have b squared minus 4ac is greater than 0. So we have a positive discriminant, and that's going to tell me it has two real solutions. And so I know that it's going to have two x-intercepts. Okay, and again, this is just going to tell me, so my graph here is going to look something like this. My graph here is going to cross the x-axis twice. The last one is that situation where I told you for now, we aren't going to be working on because we haven't learned yet about imaginary numbers. But if b squared minus 4ac is less than 0, which means that the number under the square root is negative, it means it has no real solution. It does have two imaginary solutions. Okay, now you got to be careful though. Doesn't mean a graph doesn't exist for it, okay? So this is where the graph is just not going to cross the x-axis, okay? So we can have the discriminant equals 0, we can have the discriminant is greater than 0, and we can have the discriminant is less than 0. Now, on the lower part of this page, I recapped that for you so that you have it, but we're going to practice using it. So these are the types of questions we might look at. Determine whether the graphs intersect the x-axis in 0, 1, or 2 points. Okay, so that means I have to figure out how many x-intercepts it has. It doesn't say find the x-intercepts. It just says how many does it have? What does the graph kind of look like? All right, so I'm going to identify my A, my B, my C, and I'm going to plug it into the discriminant, b squared minus 4ac. So A is 4, B is negative 12, C is 9. All right, so negative 12 squared would give me 144 times 4 times 4 times 9, okay? All right, so that gives me 144 minus 144. So the discriminant is equal to 0. So that tells me it has one x-intercept. Okay, so it crosses the graph at one point. Okay, so it intersects it at one point. Now you might look, remember I said earlier, look at that equation. That quadratic equation is a perfect square trinomial. So a perfect square trinomial is always going to have a discriminant of 0, and it's only going to touch the graph at have one x-intercept. All right, you try the next one. Decide if it's going to have it's going to have one x-intercept, no x-intercepts, or 2. Press pause and try it. All right, so we have A was 3, B was -13, and C was -10. All right, so you did B squared minus 4AC, and you got 169 minus 4 times 3 times -10. So I can see that negative is going to become positive, so I have 169 plus 120. I can already tell it's positive, right? So it's 289. So that means that it's going to cross the x-axis at 2 points. It's going to have 2 x-intercepts because the discriminant is greater than 0. So D is greater than 0. All right, guys, we're going to stop there. We're going to practice this tomorrow. We're going to look at how we might use this to help us with problems that relate to quadratics. All right, have a great day.